It began with a photograph, a single image, fuzzy, dim, barely more than a smudge of light. Yet it changed everything. It was the first real glimpse humanity ever had of a black hole. For more than 100 years, scientists had whispered about them, tried to model them, feared them, revered them. But this was different. This was real. And for physicist Michio Kaku, it was only the beginning of a revelation that would shake the foundations of everything we thought we knew. We often imagine the cosmos as distant, cold, indifferent. But what if the very things we feared in the night sky, those dark, silent giants swallowing stars whole, were not monsters at all? What if they were something else entirely? For decades, black holes have represented the most extreme edge of our understanding. Einstein's theory of general relativity showed us that space and time could bend, twist, and collapse under immense gravity. In that framework, a black hole was a one-way gate, an invisible sphere where matter was doomed to spiral inward, crushed into a singularity, a point of infinite density where physics itself gave up. Nothing, no light, no information could escape. It was the ultimate dead end. But Michio Kaku, the brilliant physicist and futurist, has just shattered that old vision. In a moment that stunned even seasoned scientists, Kaku stepped forward with something extraordinary. A new vision of the inside of a black hole. Not a singularity, not a void, but something alive. What he and his team have proposed is nothing less than revolutionary. At the heart of a black hole, he suggests, lies not a point of destruction, but a tangled, writhing sphere of what he calls a fuzzball. It's a concept born from string theory, the idea that the universe, at its most fundamental level, is made not of particles, but of tiny, vibrating strings of energy. Each string, vibrating at its own frequency, creates everything we see and know: light, atoms, even life itself. Now imagine a black hole not as an empty pit, but as a hyperdense ball of these strings, looped, twisted, interwoven, a structure that holds not chaos, but order. This fuzzball, according to Kaku's work, may be the true core of a black hole. This changes everything. Because in this new model, information, one of the most sacred principles in physics, is no longer destroyed. For years, one of the most confounding puzzles in science was the black hole information paradox. Quantum mechanics insists that information, no matter what happens, cannot be lost. But classical physics told us that black holes obliterate anything that enters. How could both be true? The answer, Kaku believes, is that the information is never lost at all. It's not erased. It's stored, encoded, woven into the quantum tapestry of the fuzzball itself, or perhaps even inscribed on the surface of the event horizon, the boundary that separates our universe from whatever lies inside. Like cosmic archivists, black holes may be preserving every particle, every atom, every moment they consume. It's a stunning shift, from destroyers to record keepers. Think about what that means. If this model is correct, then every star, every planet, every civilization that has ever fallen into a black hole still exists, somewhere within its structure. Not physically, perhaps, but as quantum information. The record of its existence hasn't been wiped away. It's been kept, hidden, preserved in the deepest vaults of the universe. Suddenly, black holes are no longer cosmic endpoints. They're repositories, memory banks, and perhaps gateways. Because this discovery doesn't just challenge our understanding of gravity or information. It opens the door to something even stranger. Kaku's findings suggest that black holes may be more than just isolated objects. They may be windows into other universes, bridges to the multiverse, passages through the fabric of space-time itself. This is where theory edges into wonder. Because if black holes are not true singularities, if they are composed of something as intricate and complex as a fuzzball, then perhaps Just perhaps, they are navigable. Not death traps, but tunnels. Wormholes. Einstein-Rosen bridges, as they were once called in theory, dismissed for decades as science fiction. And yet, here we are. The evidence may be indirect, but it's growing. Using gravitational wave observatories, like LIGO and Virgo, scientists have begun to detect the aftershocks of black hole collisions, ripples in space-time itself. In those echoes, researchers have found anomalies, reverberations that don't quite fit the models of a singularity, strange vibrations, unusual delays, patterns that whisper of structure, of complexity. Not voids, but something within. Kaku's team took these whispers and built simulations. They fed them into quantum models, string theory equations, and advanced algorithms. And what came out was astonishing. A structure that behaves exactly like the fuzzball theory predicts. Even the Event Horizon Telescope, which delivered that first haunting image of a black hole's edge, has added to the puzzle. Its observations don't just show a void, they hint at depth, at layers, at something more than darkness. And so we find ourselves standing at the edge of the great unknown, not in fear, but in awe. What if a black hole is not the end of the road, but a detour? What if falling into one doesn't mean annihilation, but transformation? What if it is not death, but a different kind of birth? These are no longer the musings of philosophers or sci-fi writers. They are questions being seriously considered by physicists, mathematicians, and cosmologists. And for Kaku, the answer may lie not just in the stars, but within us. Because if black holes are keepers of information, if they are preservers of memory, if they hold within them echoes of ancient light and lost time, then perhaps they hold something else too. To imagine a black hole is more than just darkness. That takes a kind of courage. For generations, we've been told they are monsters. Insatiable, brutal, final. They devour light, time, space. Nothing escapes. And yet, Michio Kaku asks us to look again, to consider not what is lost, but what might remain. The very nature of reality shifts when we look through the lens of Kaku's new hypothesis. If black holes are not infinite pits, but tangled cores of vibrating quantum strings, then every assumption we've made about destruction, loss, and isolation begins to dissolve. The abyss, once silent and terrifying, begins to whisper. Gravitational wave detectors, some of the most sensitive instruments ever built, have started picking up these whispers, faint echoes in the fabric of space-time itself. After two black holes collide and merge, there's a ripple, a shock wave that races across the cosmos. But sometimes there's something else, something that follows. Echoes. They're incredibly subtle, barely perceptible, like a memory of an event that has already passed, repeating itself through the universe. And those echoes don't match the predictions made by Einstein's models of black holes. In fact, they contradict them. According to general relativity, once a black hole forms, it should settle into a simple structure defined by just three things: its mass, spin, and charge. That's it. Nothing more. But these echoes suggest something richer. They suggest internal structure, like vibrations bouncing inside a solid object. And that's exactly what the fuzzball model would predict. If these echoes are real, and many physicists believe they are, they hint at a structure that resists collapse into a singularity, a structure that, instead of crushing information into oblivion, holds onto it, protects it, encodes it. And that idea that information is not lost reshapes everything. Imagine the emotional weight of that. Everything you've ever known, every moment in time, every breath of every creature that ever lived. If even a single atom of that life fell into a black hole, its story isn't gone. It's recorded, not in ink, not in memory, but in quantum data, woven into the universe's most mysterious vaults. It's a concept that reaches deep into the human heart. We've always feared loss, feared that time erases, that nothing lasts. But Kaku's model suggests something astonishing. Maybe, at the deepest level of the universe, nothing is ever truly forgotten. And that brings us to Hawking radiation, the slow, ghostly evaporation of black holes over unimaginable spans of time. For years, scientists thought that this radiation was featureless, meaningless, just the slow leak of energy, signaling a black hole's eventual death. But what if it's more? What if that radiation carries a trace, however faint, of the information inside? It's as if a black hole, in its final breath, begins to whisper its secrets back to the cosmos. Encoded in particles, barely distinguishable from the cosmic noise, are the stories of everything it ever consumed. A dying black hole might not go quietly into the void. It might leave behind a message. And now, with this new model, we might just be learning how to listen. Technology is catching up to theory in a way that few could have imagined even 20 years ago. The Event Horizon Telescope gave us our first real picture of a black hole's edge. But now, we're beginning to think beyond images. We're trying to decode patterns, the spin of particles, the shape of light, the echoes of waves. Hidden in this data might be the fingerprints of the fuzzball, the DNA of collapsed stars, perhaps even the relics of ancient galaxies. And if we can read them, we may be able to reach back in time, because in this new framework, time itself isn't what we thought. Near a black hole, time stretches, warps. Inside it, time may no longer flow at all. Some models suggest that time becomes space-like, a dimension that can be navigated, traversed, maybe even rearranged. What does that mean? It means that inside a black hole, the difference between past, present, and future may vanish. All of time could exist at once, locked in a kind of eternal now. Every moment, every cause, every effect, stacked like pages in a cosmic book. Not lost, not destroyed, but preserved. Always accessible, if only we knew how to turn the pages. This is not fantasy, it's not science fiction. These are real consequences of equations being written by today's brightest physicists, and Michio Kaku is at the center of it. In interviews, you can hear the excitement in his voice, the wonder, the reverence. For a man who has spent his life trying to unify the laws of the universe, this discovery is not just theoretical, it's spiritual. It hints at an order, a continuity, a design so intricate and elegant that it borders on the sacred, and it brings us one step closer to what he and others have long dreamed of, a theory of everything. This is the holy grail of physics, the idea that one framework could unify the quantum world of the tiny with the gravitational dance of the stars. For decades, they've refused to cooperate. Quantum mechanics and general relativity, each brilliant in its domain, but seemingly incompatible. But the fuzzball model, it might be the bridge. If string theory is right, if these vibrating filaments are real, then we finally have a common language. The math works. The models align. The data, though still early, fits the puzzle. And so the black hole, once seen as a problem, becomes the solution. It's poetic in a way only the universe can be. Because sometimes the things we fear most, the darkness, the unknown, the void, are exactly where the truth hides. Black holes were the universe's way of keeping its secrets. But now we're learning how to ask the right questions, how to decode the silence, how to see not just what's missing, but what remains. What if the next breakthrough isn't about building bigger telescopes or faster computers? What if it's about learning to interpret the whispers we're already hearing, to read the language of radiation, of gravity, of quantum memory? We're not there yet, not fully, but we're close. Close enough to know that the universe is not as indifferent as we once believed, that even in death there is preservation, that even in collapse there is meaning, that even inside the darkest corners of reality, there is light. At the edge of our understanding stands the black hole, silent, motionless, devouring. But what if we've been looking at it the wrong way? What if it's not the edge at all, but the beginning of a deeper truth? Michio Kaku believes we've finally cracked open the door to that truth, and what lies beyond it is more beautiful, more terrifying, and more profound than we ever imagined. In the old view, a black hole marked the end. Once you crossed the event horizon, you were gone. No light, no signal, no return. But now, with Kaku's latest insights, we're seeing something startling. The event horizon isn't a wall, it's a veil. And behind that veil, something intricate and brilliant is taking shape. This shift in thinking is monumental. For centuries, science has drawn a hard line between what can be known and what lies forever beyond reach. The event horizon was that line. But now we see it as a filter, a boundary that holds the keys to a deeper code. A vault door, sealed, yes, but with a lock that might just be picking itself open. Kaku's vision goes further. His fuzzball hypothesis tells us that the interior of a black hole may not just hold information, it may be information. Think of it like this. Every object that falls into a black hole leaves a signature, not erased, but absorbed into the quantum structure. And that signature doesn't vanish. It becomes part of the whole. This means that the black hole doesn't just hold energy, it holds stories, histories, maybe even consciousness. And suddenly, we're no longer just talking about physics. We're talking about memory, about identity, about the most human of hopes, that what we are can never truly be erased. There is something hauntingly poetic about the idea that ancient stars, extinct worlds, even civilizations that blinked out long before Earth was born, might still exist in some way inside the folds of these cosmic giants, not alive, not awake, but remembered. Not in the way we remember, with photographs or songs, but in the language of quantum imprint. The universe itself has a memory, and black holes, it seems, are its libraries. Imagine just for a moment that we could one day access that library. The implications are staggering. If we could read the information encoded within a black hole, we might recover the past. Not metaphorically, but literally. We might reconstruct the collapse of a star, the orbit of lost planets, the flicker of civilizations consumed long ago. We might see what the universe looked like before our sun ever burned. We might even glimpse echoes of ourselves. But there's more, because the fuzzball model doesn't just explain what's inside a black hole. It changes how we understand the whole universe. Kaku and others have suggested that black holes might connect to other realms, that the quantum structures within them could serve as bridges, not just across space, but across dimensions, across timelines, across realities. The multiverse, once the subject of comic books and speculative fiction, is becoming more than an idea. It's a possibility. If each black hole folds in upon itself, creating a bubble of space-time governed by its own quantum laws, then maybe, just maybe, each one births a universe of its own, a daughter cosmos, a branch on the infinite tree. And we might live in one of those branches. Maybe our own Big Bang was born from a black hole in another universe. Maybe the universe we know is just one room in an endless mansion, each door opened by gravity, by collapse, by memory. This is not madness. This is physics. Still theoretical, still young, but growing with every signal, every echo, every pixel of data captured by our machines. The idea that black holes could act as cosmic wombs rather than tombs reshapes the story of creation itself. And if that's true, then what lies ahead may be even more wondrous than what lies behind. The technology we're building now is like learning to read for the first time. Gravitational wave detectors are our ears. Telescopes like the Event Horizon are our eyes. Quantum computers may soon become our minds, decoding the infinite equations, the hidden language of the stars. One day, perhaps, We'll have instruments that can interpret Hawking radiation, pull meaning from its whispers. One day, we might speak to the silence and hear it speak back. This is not just a triumph of science, it's a rebirth of wonder, because black holes are no longer the end. They're no longer silent tombs floating through space. They are engines of transformation. They are witnesses. They are perhaps the most honest things in the universe. They do not pretend. They do not conceal. They contain. They preserve. And in doing so, they remind us of something deeper, something we often forget, that we are not separate from the cosmos. We are written into it. We are made of the same particles, governed by the same laws, moved by the same gravity. The same quantum strings that vibrate inside a fuzzball once vibrated inside the stars that died to create us. The universe remembers. It remembers everything. And in that memory, we are eternal. This is why Kaku's revelation matters, not just for science, not just for theory, but for all of us. It says, nothing is truly lost, not in physics, not in time, not in life. It means that love, thought, light, form, none of it disappears without a trace. The universe is not a careless void. It's a vast and intricate recorder of experience. So the next time you look up at the night sky and see a patch of darkness, know that it's not empty. It's not gone. It's not void. It's full. Full of memories. Full of echoes. Full of light too faint to see. Stories too ancient to tell. And somewhere, deep inside that darkness, wrapped in the quiet hum of quantum strings, the universe is still writing, still remembering.